Meena. Today's topic is about introduction to pointers. I'm currently studying in Sri Venkateswara College of Engineering, pursuing my bachelor's in CS with the specialization of cybersecurity. So let's learn about pointers. These are the fundamental concepts in data structure which allows multiple access of memory locations directly. They provide ability and directly manage and work with memory by offering both power and complexity in the programming. Now let's learn some basics related to pointers. First is memory address. These are the variables that store memory addresses, allowing the access to data stored in the memory location. And second is the dynamic memory allocation. They are used for dynamic memory allocation, making it possible to allocate memory at runtime. Third is efficiency. These pointers can lead to more efficient memory usage and better performance. And fourth is data structure. They are crucial for implementing complex data structures like linked lists, trees, and graphs. Now let's learn how pointers work actually. First is direct access. Pointers allow direct access to memory locations, enabling manipulation of the data stored in that memory. And second is indirection. Pointers provide a way to indirectly access data, making it possible to modify values through their memory addresses. And third is complex relationship. They can create complex relationship between different pieces of data, enabling sophisticated data structures and algorithms. Next, we'll be learning about pointers arithmetic, where we'll be knowing about increment and decrement. These are the pointers that can be incremented or decremented to move to the next or the previous memory location. And second is arithmetic operation. It is possible to perform arithmetic operations like addition and subtraction on pointers to navigate through memory. And third is array access. These pointers can be used to access elements with an array, directly providing efficient indexing capabilities. Next is null pointers. These are used to represent when a pointer does not point to a valid object or function, helping to prevent memory access violation. Second is exception handling. They are essential for exceptional cases as they indicate that a pointer is not intended to point anywhere. In detail about double pointers. Double pointers are also known as pointers to pointers. These store the memory address of another pointer, offering more complex memory manipulation and indirection. Double pointers, also known as pointers to pointers, enable even greater level of indirection. They allow us to store the memory address of another pointer, providing an additional layer of pointers abstraction. They are often used in scenarios where we want to modify a pointer by reference, such as in linked list implementations. Double pointers can also be useful when dynamically allocated multidimensional arrays as they allow for feasible memory management. Additionally, double pointers can be used in scenarios where we need to pass a pointer to a function by reference, enabling us to modify the original pointer with the function. In addition to their use in linked list implementations and dynamic memory allocation for multidimensional arrays, double pointers can also be utilized when working with complex data structures or algorithms that require dynamic memory allocation. Now let's learn about pointers and arrays. First is array traversal. Pointers can be used to efficiently traverse through arrays and manipulate their elements. And second is memory efficiency. They allow for efficient memory access and manipulation through array indexing using pointer arithmetic. Third is dynamic sizing. Dynamic array sizing and manipulation is made possible through the use of pointers, enabling adaptive data structures. Fourth is they also enable the implementation of data structures such as stacks and queues, where the size of structure can change dynamically based on the operation performed. Now let's learn about pointers and function. First is function pointers. This provide a way to invoke dynamic execution of various function, enhancing flexibility and modularity in code design. And second is passing pointers to the function. Now, these allows the manipulation of data outside the scope of the function, enabling efficient parameter passing and memory management. Third is returning pointers from function. Function can also return pointers, allowing for the creation and return of dynamically allocated memory. These can be useful for the functions that need to allocate memory for new data structures and return the pointer to turn to those structures for further use. Fourth is pointer arithmetic. In addition to regular pointers, we can also have pointers to pointers, also known as double pointers. These are useful in situations where we need to modify the pointer itself or pass it as an argument to a function. Now let's know a few common uses of pointers. First is dynamic data structures. Pointers are used extensively in implementing dynamic data structures, including lists, trees, graphs, and other complex data entities. And second is resource management. They play a crucial role in efficient resource management, such as memory allocation and deallocation, offering flexibility in resource usage. And third is system programming. Pointers are essential in system programming for addressing memory, interacting with hardware, and optimizing system performance. Thank you for watching my video.